Okay, ma? See, ma. So, next we are studying about resistors in series connection and parallel connection. So, see here, R1, R2, R3, what kind of connection is this one? Definitely series connection, no, ma? And what is the battery capacity we are connecting? V. So, this potential, it will be divided among three resistors, no? V1, V2, V3. Clear, no, ma? Do you remember in series connection what happens? In series connection, current produced never divides. Through first resistor also, second resistor also, third resistor also. Through every resistor, same amount of current will flow. Current is same. Okay? But what happens to the supply potential? It gets divided among all the three resistors. This is what happens, no? So therefore, what are the note points here we have to write? Current remains the same. Current remains same in all resistors. Okay, ma? So then what about potential? Potential is divided. Potential is divided among series resistors. Among series resistors. This is what happens, no? Clear, no? Now, total supply potential V, I can write it as V1 plus V2 plus V3. Can I write like this? What is the supply potential we have given? V. So this V gets divided into all the three resistors. Basic definition of potential, do you remember? What is meant by potential? Work done per unit charge. This is potential. Sima, what does resistors do? Resistors ఏం చేస్తాయి చెప్పండి? They oppose the flow of current, no? They oppose the flow of charge. But battery will push the charges through the resistors, no? So it means battery must do some work. Battery కొంచెం వర్క్ చేయాల్సిందే కదా. So it means that this is nothing but work done by the battery to push the charges through the first resistor. This is the V2 is the work done by the same battery to push the charges across the second resistor. Potential is nothing but work done on that particular resistor. Are you able to understand? So total work done, it is divided as V1 plus V2 plus V3. Okay. Now what is this V? This is total supply potential, no? In terms of Ohm's law, how can I write supply potential? I can write I multiplied by R equivalent. I can write now according to Ohm's law. According to Ohm's law, what is the equation? V is equals to I into R. Clear, no? So what is I? Current flowing in the circuit. What is R equivalent? Total resistance of the circuit. R equivalent ante ade kada. Total resistance of the circuit. Now can you say how can I calculate V1? What is V1? Potential difference across R1. How can I calculate? Suppose, what is the current flowing through this resistor? I only know. What is the resistance of this one? R1. That's all, no? Now write the similar values. So I into R2 plus I into R3. Clear, no? So I values if I cancel, then R equivalent is equals to R1 plus R2 plus R3. So this is the equation to calculate equivalent resistance if resistors are connected in series connection. Okay? So in capacitors, do you remember? When capacitors were in series, what was the formula? 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C2 for series. But here for series, just to add all the resistors. Okay? So total resistance increases or decreases? Increases, no? So make note of that point also. So in series connection, okay, ma? So total resistance increases. Total resistance increases. Okay? Are you able to understand? But in capacitors, total capacitance decreases if they were connected in series. But here it will increase. Okay, ma? That's it. Now let us go for the second type of connection, which is called parallel connection. Okay, ma? So parallel connection. What is meant by parallel connection? So here there is one resistor, second resistor, third resistor. All of them, they are connected to same potential. Okay, ma? This is plus and this is minus V. So this is R1, this is R2 and this is R3. Clear, no, ma? So this kind of connection we can call it as parallel connection. Clear, no? Now can you say in parallel connection what is the importance, ma? Which divides, which doesn't divide? Current divides. Voltage does not divide. Potential difference does not divide. Clear, no, ma? So therefore, if I amount of current is produced in the circuit, so this I amount of current is divided into I1, I2 and I3. It is divided like this. Clear now? But what about potential? Listen. Here if I consider potential to be 0 volts on the negative side, on the positive side I have to consider potential to be V volts. Clear no? Because there is a rise of potential. No? This is negative, it means lower potential. Positive, higher potential. What is the rise of potential? V. Rise of potential is V. So here if potential is 0, here potential should be plus V. And here if potential is plus V, what is the potential here? Here also V only, no? Because in between these 2 points there is no consumer of voltage. Voltage ni consume chese component edi ledhu akkada. So same potential will be applied here also. Similarly here if it is 0, then here also what is the potential? Here also it will be 0 only. Clear no? Because again in between these 2 points there is no consumer of voltage. So therefore if you see across any branch, same potential difference is existing. V minus 0. Across this branch also V minus 0. Across this branch also V minus 0. Are you able to understand? So across every branch, same potential difference will be applied. Arthamautundi kada? So therefore what are the note points here we have to write? Note points is that here potential does not divide. Potential does not divide. Okay ma? Across every resistor, same potential is applied. Okay ma? That's all. No? Similarly, one more point which I can write is, but current divides. Why current divides? Because it is finding new routes. Okay? Okay, ma? So why does current divide? Ma? Because it is finding 3 different routes, no? So if it finds routes, definitely it will divide. Are you able to understand? But current divides. So total current, can I call it as I1 plus I2 plus I3? Ma? That's all, no? Total current I can write like this. Current produced in the circuit is I. Current found in each of the branches is I1, I2, I3. And again according to Ohm's law, I can write I is equals to V by R, no? Okay, ma? What is the total potential of the circuit? V. What is the total resistance of the circuit? R equivalent. Clear, no? Next I1. Can you say how can I write I1? V by R1. That's all. I1 is the current in this branch, no ma? In this branch potential difference is V only. But resistance is R1. So V by R. Okay. Plus V by R2 plus V by R3. So V get cancelled. So therefore I will write 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay ma? So this is the equivalent resistance when resistors are connected in parallel connection. And here total resistance is increasing or decreasing? Decreasing. Whenever you connect resistors in parallel, total resistance reduces. Okay? So that is the note point. Note point is that total resistance reduces. Total resistance reduces in the circuit. Okay? That's it. See, so current in 2 parallel resistors. So these are 2 resistors and they are connected in parallel connection only, no? And what is the supply potential? Supply potential is V. Current produced is I. I is getting divided into 2 branches. Okay? So if I want to calculate I1, then the shortcut formula which we have is total current multiplied by R2 divided by R1 plus R2. This is the formula. Clear number? What is I1? I1 is the current in first branch. You are multiplying total current multiplied by, first you take resistance in the second branch. This is the resistance in second branch, no? So R2 divided by, then you write the total resistance, RT, R1 plus R2. Are you able to understand, ma? Similarly, I2 value, how can I write? I2? I2, I multiplied by R1 divided by R1 plus R2. Okay, ma? So this is how you can write. So these are very important equations, ma, which are very helpful in doing the calculations. So there is some proof also. I don't think it is necessary. Remember this concept. So let us see this question. So 2 coils connected in series have a resistance of 18. It means R1 plus R2 is equal to 18, no, ma? When they are connected in series, this is the formula we use, no? R1 plus R2 is equal to 18. So, and when they are connected in parallel. Parallel means what? 1 by R is equals to 1 by R1 plus 1 by R2. This is the equation for parallel connection. No? Or same relation I can write like this also. R is equals to R1 R2 by R1 plus R2 by taking LCM. And when they are connected in parallel connection, the equation, the value is 4R. That's all. No? Now, by using these two, we are supposed to find out the individual resistances. You do one thing, you take this R1, R2 and substitute here. Let us see if we get something. So, R1, R2 by R1 plus R2, instead of R1 plus R2, I can write 18 is equals to 4. Clear number? So, therefore, R1, R2 value is how much? 18 4s are 72, na? 72 only, no? 72 ohms. Okay, ma? So, this is R1, R2 value which we got. Now, I have R1 plus R2, I have R1 into R2. So, if you look at these two equations, what do you understand? I can do one thing, no ma? See, we have a formula whenever you get this type of situation. So, R1 minus R2 whole square can be written as R1 plus R2 whole square minus 4R1 R2. This is one formula. Clear, no ma? So, R1 minus R2 whole square is equals to R1 plus R2 whole square minus 4R1 R2. You expand it and check it. Definitely you will get both of them, they are equal. Are you able to understand, ma? Now, in this equation, let us substitute the values which we have. So, R1 minus R2 whole square is equals to R1 plus R2 is 18. 18 square minus 4 into R1 R2, 72. Okay, ma? So, 18 is 324 minus 72 4s are 28, 288, 288. Okay, ma? So, 324 minus 288, 24 plus 12, 36. So, 36 ohms. I got answer up to here. That's all, no, ma? Now, once I have R1, R2, R1 minus R2 whole square is 36, no? So, therefore, R1 minus R2 will be how much? Root 36, which is equal to 6. Also, I have R1 plus R2 already I have, no? So, this is equal to how much? 18. So, just add both of them. Clear, no, ma? So, 2R1 is equal to 16 plus 18 is 24. So, R1 is 12. Okay, ma? So, R1 plus R2 is 18, no? So, therefore, R2 value is 6. So, one is 12 ohms and the other one is 6 ohms. That is my answer. Okay, ma? Anybody? Any idea how to do this calculation? In capacitors, we have done this type of problem, no? What do you understand? This is a Wheatstone bridge, ma. This is a Wheatstone bridge. Godhumaral lavantena ide. Okay. So, how to redraw this circuit? Clear? Let us see. So, this is A, this is B, let us call this is C and this is D. Okay, ma? So, therefore, A to C, I will draw one resistor. Okay, ma? Then A to D also, I will draw one resistor. A to D also one resistor. I will draw up to here. Okay, ma? Then from D to B, there should be one resistor. D to B. This is one resistor. And in between B and C also, there is one resistor. This is one resistor. Clear, no, ma? And in between C and D also, there should be one resistor. That's it. And terminals are A and B, no? So, this is my terminal A, this is my terminal B. This is the circuit. Okay. Now, the question is whether it is a balanced Wheatstone bridge or not. How can I find out whether it is balanced or not? Product of opposite resistors should be equal. 2 into 2, 4. 2 into 2 is 4. Okay. So, therefore, this is a balanced Wheatstone bridge. Okay, ma? So, if it is a balanced Wheatstone bridge, potential at C and potential at D will be equal. Already we have discussed this point. Potential at this point, it will be same. If 2 points are at same potential and if there is resistor, then current cannot flow. If current cannot flow, then there is no use of this resistor. I will remove this 2 ohms resistor. Now everything is connected in series and parallel. 2 plus 2, 4. 2 plus 2, 4. So therefore, how can I draw the circuit? This is how I can draw the circuit. This is 4 and this is 4. Okay, ma? So 4 and 4, they are connected in parallel. So therefore, equivalent resistance is 2. That is my answer. Understood, no? Very simple. Anybody, can you say, ma, what is the resistance of this circuit? Nobody? This is also a Wheatstone bridge, ma. This is also a Wheatstone bridge. Already this type of circuit we have drawn in capacitors, no, do you remember? Wheatstone bridge. So prove it is a Wheatstone bridge. So let us call this point as point C and let us call this point as point D. Okay, ma? So from A to C there is one resistor. Okay. And from A to D also there is one resistor. A to D. One. Each resistor is R. So, and still between C and D there is one resistor. Clear, no, ma? And from D to B there is one resistor. Let us call this point as point B. This is D, no? D. So D to B also there is one resistor. And from C to B also there is one resistor. That's it. Each resistor is R. So definitely this is a balanced Wheatstone bridge. R. R is correct. So if it is a balanced Wheatstone bridge, so potential at C is equal to potential at D. That's all, no, ma? So therefore current does not flow in this branch. Okay. So if you remove the branch, then this is the circuit diagram I can draw. These two resistors in series, no? 2R. These two resistors are also in series, 2R. So 2R and 2R, they are in parallel. So therefore, I will get a single resistance of resistor R. That is my answer. Okay. Sima. So this is the given circuit, ma. We are supposed to find out equivalent resistance between A and B. It means battery connection is where? Battery connection is present between A and B. Clear, no, ma? So this is the given circuit. Now if you see this circuit, the current, for example, it enters like this. Clear, no, ma? So this current, after entering like this, it gets divided into these branches, again gets divided here, again gets, now when current reaches here, now can you say what happens, ma? Here it is seeing two branches, no? So wherever, hall tickets detin dilale. 1 minute. Okay, ma? So, see, ma, in this circuit, the current after reaching here, it doesn't further divide, ma. Okay? For example, if I say here current is I dash, okay? Same current I dash will enter into this 4 ohms resistor also. Current doesn't enter into this 2 ohms. What is the reason? See, ma, whatever current is distributed by the battery, again it should enter the battery also. Are you able to understand? So that is one important point which you should remember. Note point is that total current leaving the battery, must be equal to total current entering the battery. Total current entering the battery. Understood, no, ma? Okay. So whatever current is leaving, same current should enter also. But if current enters into this branch, can it re-enter into the battery? It is not possible. So you can say this type of connections, they are open circuited connections. What kind of connections you call them as? Open circuited. They are not connected in the circuit. They are definitely present in the circuit, but connection wise they are not connected in the circuit. So therefore this 2 ohms and this 2 ohms, they are not connected in the circuit. Okay? Because the current, once if it enters into these resistors, again it cannot re-enter into the battery. Whereas all these currents after flowing in the resistors, again they will re-enter, no? Again they will re-enter the battery. Okay? So for example, if 10 amperes is leaving the battery, 10 amperes should enter the battery also. Is it clear? Then only our circuit diagram is correct. So therefore, these 2 ohms and these 2 ohms, they are not connected in circuit. So you can remove them. Okay? How can I remove? I can remove like this. Okay? Now I have already said you, whenever you solve this kind of problems, you should start from the back. Venakal nunchi start cheyali. Okay? Now see. So 2 plus 2, 4. 4 plus 4, 8. 2 plus 2, 4. 4 plus 4, 8. 6. This is 6. This is not 6, this is 4 ohm. This is 6, this is 6, but this is 4 ohm. Are you able to understand? So 2 plus 2, 4. 4 plus 4, 8. 8 plus 4, 12. So totally I can say 12 ohms resistor, it is connected in series. Can I say like this? Clear now? 12 ohms resistor is connected in series. Now you see these 2 resistors, parallel or series? Parallel connection, no? So therefore 6 into 12 divided by 6 plus 12 is how much? So 6 into 12 divided by 18. So 6 1s are 6 3s are 4 ohms. Clear, no? So therefore instead of these 2 resistors, again I will write a single resistor of resistance 4 ohms. Clear, no? Now you come up to here again. So 2 plus 2, 4. 4 plus 4, 8. 8 plus 4 is 12. So again instead of all of them, you write a single resistor of resistance 12 ohms. Okay? Again same story. 12 into 6 by 12 plus 6 is